So this is a rate of reaction demonstration where we're going to take the chemical reactions that produce the energy, okay, the free energy given off by the spontaneous chemical reactions in the battery that will power this radio. It's an older radio, it's got a cassette deck, it's got a CD player. I'm going to run the FM radio part here when the battery is connected. And so this older radio does run through AC current. I don't have it plugged in here. Okay, you can see that that's the cord. And all I'm doing is taking these leads, these electrical wires, and connecting it to the back of the battery, or at least the back of the radio, to connect it to the positive and negative end of the battery. And of course, it runs by putting batteries in series. Now the batteries that go in the back here, of course, are C, and these are AA. And now I'm going to use smaller batteries to hopefully show a change in the effective temperature grader. Batteries that are smaller, of course, less diameter, takes a short amount of time for these batteries to get cold, and that's the demonstration here, is temperature affects rate of reaction of chemical reactions because the collisions go slower inside these batteries, and which, by the way, this battery backpack is run in series, and each one of these, okay, batteries is approximately 1.6 volts, and in series, because I have 8 of them, I'm going to have in this brick, I'm going to have the 12 volts necessary to run this radio. So I'm going to connect the leads, again, that go to the back of this radio that's just connected. And I did have a student years ago do that for me nicely to make it nice and easier. It was Brandon McMahon. And so again, that's where the C battery is connected. You can see the cord here connects. And all I'm going to do is run the leads from the positive and negative end of where the batteries go. And I'm running it into this brick, okay? And this 8 AA brick. So in any case, I'm going to put this radio back into its area here in the video, and we're going to bring this here, and now I'm going to turn the radio, well, the radio is already on, but you don't hear anything because we don't have all the leads connected. I have the positive lead here, and now I'm going to just connect here, all right, to hopefully bring the power necessary to run the radio.
Tall and bearded captain to whom everyone looks
in all of its glory. You can hear the radio in the background. All right, and I'm going to, again, it's a rate of reaction demonstration. So what I'm going to do is put this brick, okay, I'm going to slow this down. I'm just going to have to walk over, hear myself talk over the radio. It's on. Okay, but I'm going to put this battery pack back, a brick, so to speak, and I'll push this back a little bit so we have some room. Okay. So I'm going to put this into this container, plastic container. Now, I do know that liquids could short out, so I'm going to put this battery pack brick here of 8 AA's that gives me the 12 volts, and I'm going to put that, okay, in a bag so that the liquid nitrogen doesn't short out, okay, and that's all. I'm going to submerge these batteries. Again, it's a temperature demonstration. Okay, what am I trying to do? And show that, well, if temperature drops, the rate of collisions in these batteries that create the voltage, okay, or flow of electrons, all right, to power this radio is going to decrease, okay? And therefore the radio should stop or slow down after some period of time. So let's stop talking about that and do that.
Dynamics. If you're up there for a long time and there's 5,000 of you, you know, who really is in charge? Do the people in first class stay in first class? Do the people in economy stay in economy? Is Herman Judd, because he owns the ship, is he the leader? Well, you know, it's about something else now. And it's about everyone measuring up their own worth, really, and how they can contribute to the rescue. And therefore, people questioning themselves and whether they do anything useful in their lives. And every episode is looking at questions like that.
Well, it wasn't such a short answer.
I'm going to raise the volume up.
No, it wasn't. No.
And we're going to wait. We're going to wait to see.
Yeah, but I can do longer. So relatively speaking,
that the batteries, which is a chemical
I have to ask, though, this is
cells,
sort of your jam, for lack of a better word. I mean, you've made a career out of satires that skewer people at the top. In the Loop, 2009 film, Veep, obviously. Mm-hmm. What is interesting to you about this kind of incompetency?
Well, I mean, I try not to make the people involved, you know, habitually incompetent. It's more how the pressure that is put on them from outside and from all around forces them to start making compromises or forces them into a panic. I think what fascinates me is
And there you go. And there you go right there. So you can actually measure how long that took, and it didn't take that long. These batteries got too cold. And these batteries got so cold that the collisions, okay, slow down so much that there's just not enough collisions, okay, to have the chemical reaction and therefore produce the energy in this, which was a spontaneous reaction at approximately 20 degrees Celsius, is not spontaneous at this temperature, okay? And so it's a reason why when you try to turn over a car, okay, with a 12-volt battery, and it doesn't matter what the size of the battery is, but to start a car in the morning, it's really cold out, especially in places where it becomes below freezing. It's harder to start cars. In really extreme cold conditions, they use warming blankets, okay, to keep cars or engine blocks warm, okay. And another way to think about this is also to preserve batteries. People put them in the refrigerator or the freezer, okay, because if you're stopping and slowing down the reaction, you're slowing down the natural discharge of the battery and preserving the reactants, which contain essentially the free energy that we use. All right, so I hope you enjoyed that rate of reaction. Temperature drops, the rate of reaction drops. In this case, we can see that the chemical reactions dropped in the battery and therefore produce less energy, free energy to run the radio.